Hello and welcome back, grade 7 of South Africa and across the world. We are here again with Maski Learning and Maski TV. I'm very sure that you guys were waiting for us and wondering how we're going to start. So as always, please grab your pen, pencil, ruler, and your writing pad or a book. Sit and relax. We're working together to try and analyze the geometry of straight line today. Stay tuned and hit the ground. What are we going to do in the geometry of straight line today? We're going to focus solely on the definition of the geometry of straight line. We have types of lines that are created and that we have to know and understand as we are in grade 7. So here you can see we have listed them. At the end of this lesson, we need to be able to define and distinguish or differentiate between different lines that we have. We have line segments, we have a ray, we have straight line, we have parallel lines, perpendicular lines, and something we call transversal line. We all have to understand these different types of lines, which people will say, but it's just lines. Yes, it is just lines, but the lines, they are made by a particular point. So every time where you have to have lines, it has been created because many small points have joined together to create that particular line. So therefore, we decided to start by defining what a point is before we start talking about the lines. So a point is actually a particular point, a location where it's showing exactly a position of something. So suppose you have a line. In any line that you have, you can then have a point. So if I have a straight line like this, in a straight line, and I have a point there, I have a point. So the moment they come together, packed together, they then create a line. A point or a dot cannot have any length or width or thicknesses. So it's just a point. So it can be as small as that. It's a point. It can be a little big. It's a point. So that's why we are saying it's not determined by the length, the width, or the thickness. The points are used mostly in naming particular lines. So if we have a line and we want to say you have moved from point A to point B, we then say from where you were standing it was A, and where you're going to end it's a B. So all those have names, and that's what we're going to try and define. The point can also be labeled with capital letters like A, B, C. So within the lines that are different, you would see when we have one point and the other, we're always going to have them with a particular the particular point or a line. So here we go. We have a point that we say it's a line segment. So a line segment is literally a set of small points that comes together to create a line like this one, but it's going to have a start and an end point, which we can come and label them either A and B, so that we say this line segment is called AB, since it's starting from A and it's ending at B. So this is called a line segment. Anytime you see a line that has points, we know now that's line segments, right? Then we have another type of lines that we call rays. So a ray is where you are starting and to where you don't know where you're going. Take it as a trip, going to where you don't know. Suppose your family want to take a trip from one point to another, and you know I'm moving from, for example, Limpopo, that will be my point A, but where I'm going, which I don't know, perhaps Durban, which I don't know, that will be the point I don't know. So this arrow seemingly represent the fact that I don't know where I'm going to end, but I know I'm starting here. So that's why we have a point and we have an arrow to represent that. So it has a starting point but does not really have the end. It just has an arrow that shows the direction that I am going this way, but not knowing where I'm going to end. Right. Then another one which we have, it's called a straight line. This one is our famous one. Remember? Our topic says geometry of straight line. So hence it's famous. So a straight line can come from somewhere to somewhere. So it starts with a particular definite point. So it's not like you're going to find a point, I'm starting here and I'm ending there. That is not your straight line. It's literally your line segment. So your straight line can be any line that is straight without a starting point and without an end point. But we use the arrow to show that every point that is going to be in that line from wherever it's coming from, it's literally called a straight line. So that's how we define our straight line. Then we have lines that we call parallel lines. Now, with the parallel lines, I am going to try and give you few minutes for you to try and remember what we spoke about in the previous lessons was about parallel lines. I need you to settle and try and ensure that your parallel lines information are back to your brain. For like 2 seconds, I'll give you a moment and you guys analyze your parallel lines. I'll be right back. Yes, of course, we have talked about parallel lines, and that's why I gave you a moment to look at them and refresh. So our parallel lines always will have a particular arrows that we have talked about. Remember, when you have some arrows like this just reminds us that this line AB is actually parallel to line CD. So this is our line segment. You can see they have a starting point and the end point. So they are called line segment. So parallel lines always will have the equal distances between the two lines. 1. 2, it will always have the arrows that indicate what is parallel. So that is the 2 things that you check. Is the distance equal between the line? Yes. Do I have arrows? Yes. So therefore, my line segments are parallel. Okay. Take it like every time you have a parallel lines, you should not really forget these 2 things. As I've indicated, having the arrows and also ensuring that the distance between your parallel lines is the same. So that is very important, right? So sit back and let's see. So imagine when you are having the road as well, going from one point to another. If you check here, you can see that if these lines were not parallel, or if there was a line that goes this way in between, most of the cars could have made accidents. So do you see how geometry is saving our lives? Because if I am going straight like this and someone was coming this way, would be hitting each other. But geometry made it easy and ensure that we actually have parallel lines ideology or idea that has been used to create this road. I am very sure that from now on you always remember parallel lines, and you won't forget that every time we're on the line we are using the skills of parallel lines which have been used by those engineers. Be careful, do not create lines that are not parallel, because you're gonna make us have accident on the roads. Okay, now we have the line that is drawn to just in a parallel lines. For academic case or for calculation case, when we go on, you would see that we have a line that goes like this. We call this line a transversal line, right? We call the line a transversal line. We call this line here a transversal line, right? So what does the transversal line mean? It just means that it intersects 2 parallel lines, 2 or more parallel lines. If they are not parallel, then the line is not really called transversal. So it's called transversal line because it intersects 2 parallel lines or more parallel lines, right? Then we have one other line which is called perpendicular line. So perpendicular lines, if you remember when we were doing construction, we have constructed the perpendicular line 90 degrees. So whenever you see 2 things that are on your space or 2 lines that are on your space, I use an example of a book, in most cases a door, right? So you have your book here. There's a line going this right, and then there's a one that is going horizontal. This corner here, it literally tells us that the line here that is going horizontally, vertically down, and the horizontal one, where they intersect, is actually our angle 90, and that angle, therefore, it's called perpendicular angle, right? So that angle is called a perpendicular angle. So with that being said, this is our sine that is 90 degrees. So it's either we write the 90 degrees or we put the perpendicular there, right? So that is the perpendicular one. Also, with the perpendicular one, if you remember very well, in each and every road, there's someone where we go, we call it a T-junction, right? If we go and you find a T-junction like this one, this is the one that shows literally that this there is some sort of geometry that has been used for them to understand that this is a T-junction. That is why when I'm on it, I can be able to turn left, and then someone can still pass without us bumping each other, because the perpendicular idea was used to ensure that this is perfectly done in this way. So with that being said, as you guys are looking around, finding your parallel things at home, also find your perpendicular things at home. I am very sure you have a lot. So start looking around and check what is perpendicular, check what is parallel. I am doing the same on my side. You see, I just found my T-junction here. It's called T-squared for the engineering things. So that's one. And you can find yours and see what is parallel and what is perpendicular. And after that, we're going to start doing it step by step, how we're going to deal with the calculations that you guys have to know, answering the questions of parallel, perpendicular, and all the lines that we have learned by now. Hello and welcome again. I'm very sure you guys are engaging and excited. We just have one question from Mitla. Mitla, we're going to respond to your question now. What he or she said is that when you draw this, if you don't put the arrows into the parallel lines, is it wrong? What do you guys say? What do you think? Pop it on the chat and let us know if it's wrong or it's correct. So if you have your two lines, but you don't put the arrows as we have indicated here, which I'm just running back to it. If you don't put the arrows here, is it that wrong or is that correct? Can we have the answers on the chat? So we have the two lines, but we are not saying or we are not showing how are they parallel. Okay, so I am going to try and draw them like this. And I'm going to try draw the other ones like that. Then I call this one A, B, C, D. Another one A, B, C, D. In geometry, for as long as things are not told to you, you cannot assume. So I can come and argue that AB is actually parallel to CD. And someone can come and argue that AB is parallel to CD. What is the difference? And which argument between argument A and argument B is valid geometrically? Mitla, with this, I'm trying to indicate that if someone come and tell you that these lines are parallel, you need evidence that they are parallel, which most of the proper evidence will when you have your arrows. If you don't have the arrows, you cannot assume that they are parallel. Therefore, it's crucial that you put parallel lines with the arrows every time you deal with them. So yes, if you don't put your arrows, then nobody can confirm that those are the parallel lines unless they were proven that they are parallel, right? So we always have to put what? Our arrows to indicate the parallel lines. Okay. I hope you guys got that, all of you. So let's try and respond to this together as well. So the question says, we took this sorry, from our platinum textbook, page 32, grade 7. So if you have your platinum textbook, this book, please just open page 32 and then we work through it together. So don't even shy away. Those who don't have, Here is the questions. Let's work on it together and respond to them as we should. So the question says, say whether the following line segments are perpendicular, parallel, or neither, using the correct notation. Right. What are the notation that they are talking about? If you remember very well, when we were doing the other construction, I did give the notation to say that if AB is parallel to BC, let me write it properly. Okay, if AB is parallel to CD, for example, this is the notation we use for parallel lines. So that's how you're going to write them, right? If you are saying that AB is parallel to CD, then you're going to do that for number 1. That's an example. Then for perpendicular, if it was AB, which you are sure that is perpendicular to CD or BC, then you're going to write it like that. AB is perpendicular to. So what notation are we talking about? The parallel notation and the perpendicular notation. Right. So let's start, or let's go with this. The first question, it says we have ABC, that is our line, but with an angle 40 degrees, and there's a line CD. Is that perpendicular or parallel? Please put it on the chart, or it's even neither. I am sure that that is neither, right? So I'm going to put just an N to show that it's not. And number 2, did anyone put it on the chart? What will AB and XY be? AB and XY will be, yes, perpendicular. Why? Because we have the 90 degrees. And remember, we did say that every time you see your 90 degrees, that means that they are perpendicular. Those line segments are perpendicular. So that's what it means. Number 3, we do have our 90 degrees there at E. If you check very well, there is our small 90 degrees. Therefore, our EG is going to be perpendicular to EF or FE. Right? Then we go to number 4. Number 4, it shows that we have EF and EG with the arrows. Remember? So that shows that our 2 line segments are literally parallel to one another. So you're going to come and say EF is parallel to GH. Right. Then we come to 5. Remember, one of the properties of parallel lines says the distance between must be equal. So we can see that we have 3 and we have 2. That makes it not parallel. So we are going to say that AB in this one is not parallel to CD. So we have 2 things that we can categorize. The first one, it's not even parallel or perpendicular. Also, the 5th one is not parallel or perpendicular. I hope you guys have got that and you managed to understand what we need to do to understand that this is perpendicular or parallel. Okay. Our second one, similarly, can we quickly just put it on the chart as we are? Remember, this is a working together kind of equations. I don't do this alone. If I do it alone, then you guys won't understand. So we have to do it together. As we are doing this one, the second question, which is still coming from our Platinum textbook, it says determine which lines are also perpendicular or parallel in the following diagrams. We gave you diagrams, there are only 4. Just find out which one is perpendicular and which one is parallel. Okay, let's start. Number A, we have AB and we have CD, right? There is a 90, which is an evidence that AB is perpendicular to CD, correct? Number B, what is an evidence there? 90 degrees. You're right. So that shows that we have EF perpendicular to GH. Just like that. Right? Then when we come to C, we can see that we're starting to have many, many lines and many other information. If you remember very well, on one of our session, we indicated that if you have more than one parallel lines, then the arrows will keep on increasing. If the arrows are the same, then that means that all the lines are parallel, which is not true. So we have our EF and then GH with one arrow. If you check this one, it has one arrow. So that means these are the two parallel lines. When you write it, you're going to say EF is parallel to GH. And when you write that, that is only for that one. When you check the other lines with two arrows, A, B, and C, D. So that means you are going to say AB is the one that is parallel to CD, because they have the same arrows. So if you check, they have double of the arrows that the other ones have. So therefore, they are the only parallel ones, right? There's nothing to say about perpendicular because we are not given any 90 degrees or any sign that shows that we have perpendicular lines. Even though we know that at some point that the distance must be equal, but we are not so sure that this will be perpendicular as well because it was not given to us. So we cannot just assume. Hence, we cannot say anything about that. Then when we go to D, we can see that this angle here is 30. And if the angle is 30, automatically that is saying that this one is neither parallel nor perpendicular. So that means number D, KL is not parallel to LM, as well as KM is not perpendicular to LM. So this one, you're going to just write it down and say KL is not parallel to LM, as well as KL is not perpendicular to LM. That is very important that you put it down because you would have to get marks for it as well. I hope you guys have enjoyed and have understand that while you are popping the question for us and ensuring that you can understand this thing. I hope you have it with you. I'm going to give you 1 more minute for you to double check the current one, and then we are going to work on it to ensure that you guys understand. So at this time and moment, as I leave this on the board, I need you to write quickly for like 30 seconds or so. When I come back, right after the break, you have all the solution and the answers on the chart. Stay tuned. Yes, of course, you guys are geniuses, and I'm very sure that you have managed to get this one right. But before we run to that, we do not run and leave each other behind. I have Tapelo online who have asked one question. The question was, what is a right-angled triangle? Or what is a right angle, for example? So when we are explaining this one, I'm sure that Tapelo will understand what is a right angle, and I'll use that word a lot so Tapelo can relate. So let's quickly just grab this as we answer Tapelo together with this question for Tapelo to understand. Okay, so here we're told identify and name the parallel and perpendicular lines at this figure below. So we have the figure A, B, C, D, E. So we can count it like that. So there's many triangles in there and many other things. I think there's 3 triangles, and we do have our right angle triangle, our triangle, rectangle, I mean to say A, B, C, D. So we have our rectangle there and we have our triangles. But our solely focus will be the perpendicular lines and also the parallel lines. So before we can even do anything, we need to identify what we are going to work with. Because when we are working with perpendicular and parallel lines, we do not deal with a triangle. So here, for example, we have our line, which I'm going to just do this onto it. So if you check here, what I'm trying to highlight, that is our rectangle ABCD. That's our focus. So with a rectangle ABCD, we have AB with 2 arrows and CD with 2 arrows. So that means we have identified our parallel lines. So we have naming it is by saying AB. So that is a name. And also CD, that's naming, but we are saying that they are parallel to one another. So identified, right? Also, we have AC parallel to BC. Remember, this is your ticket to parallel, right? So we have AC parallel to BD. Are we okay? So we have seen that, right? With that, remember the properties of a rectangle. Do you remember them? About the angles, can you pop it on the chart for us? Yes, of course. A rectangle always have a 90 degrees somewhere where it is. So here it's our 90 degrees there, and also we have our 90 degrees there. Do you see it? They are there by the corner. So that symbol means that AC is also perpendicular to CD. So we're going to write that AC is perpendicular to so this is our AC and that's our CD. Let's do this. Right. Again, we have our AB perpendicular to BD. So AB is perpendicular to BD. Because this is a rectangle, also our angle A is going to be 90 degrees and also our angle D is going to be 90 degrees. So therefore, that means that even if you go backward, you're still going to have our AC perpendicular to AB, right? So you're going to just go around them. As you do that, you are going to understand your right angle. So this is 90 degrees is the angle that we call right angle as well. So that's our right angle, and that is our 90 degrees angle, which is shown by the corner. Remember, everything, the corner of your book, at home, at the door, the houses, and all those, they are actually your right angle. That is it. That is a right angle. And I hope for Tapelo and everyone have understood what a right angle is all about, and they have understood the concept of the straight lines with all that they can. I am happy to keep on answering to the questions as much as possible, but I do have a friend and I do have support that can help you guys to learn more. Remember, for you to master the maths, you need to keep going as much as you can. Keep on practicing, keep on watching Maski TV, and don't forget to just find our friend, and the friend will help you to do more. If you want more, just go to Maski. If you don't have Maski as yet, you can just save the numbers 072 091 0388 and ask Maski to support and tell us on the chat what it is that you want to see next time and what it is that you want us to teach you on, assist you to ensure that your education, it doesn't look more like some of us. It's changed and it has a direction. At Maski Learning, we are here to support you in all directions that we can. With that being said, I'll see you next week, and I hope you guys have enjoyed the lesson as we go into a whole week for you guys to enjoy your school. Stay tuned. with Maski Learning, with all our socials, our Maski TV, and also our Maski friend who is there to support us on WhatsApp just for free in all the time, all for you. Please call your friends, the parents, and all other educators to come and join us to enjoy this time with Maski Learning and Maski TV. From me, Teacher Thandi, thank you so much. See you next time. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.